Welcome back to the deep dive. We have a really fascinating one today. We are looking at Science of Strength Training by Austin Current.
Hmm.
And I think the best way to frame this right up front is that we aren't really talking about working out today.
No, definitely
Yeah.
not. Not in the usual sense.
We aren't talking about, getting a pump or how much you bench press or what the coolest new active wear is.
Right.
We are stepping into a laboratory. We're stripping away the gym bro culture and looking at the actual biological machinery that keeps you moving.
Which is so refreshing because if you walk into a typical gym, it is, it's honestly overwhelming.
Totally.
You have machines, cables, free weights, people grunting, loud music, and everyone seems to be following a different set of rules.
It's so intimidating, and Austin Current points that out right at the start of the book. He says the biggest barrier to entry isn't physical readiness, it's information overload.
Paralysis by analysis.
Exactly. You stand there looking at a rack of dumbbells and think, if I pick that up, am I going to hurt myself? Am I
Yeah.
doing it wrong?
And this source material is really designed to be the antidote to that anxiety. The goal isn't just to tell you what to lift, but to explain why lifting works at a cellular level.
It's about decoding the signals.
Yeah, the signals your body sends and receives.
So that's our mission today. We are going to decode the human body. By the end of this deep dive, I want to understand why my legs shake after a squat, what is actually happening inside the muscle when it grows.
And why your skeleton is doing just as much work.
Right. Why it's not just muscles.
It's a real shift from viewing exercise as a chore to viewing it as a stimulus. You're essentially hacking your own biology.
I love that. Hacking biology.
Huh?
Okay, but before we can get to the hacking, we have to clear the debris. The book starts by addressing the mental game.
The psychological barriers.
Because before you even touch a barbell, there are these myths that stop people from even trying.
Right.
And the first one is the classic excuse I think we've all used at some point. I have bad genes.
Oh, the genetic scapegoat. This is such a fascinating area of research. We often treat genetics like a verdict,
Like it's your destiny.
I'm an ectomorph. I'm naturally skinny, I'll never be strong. Or I'm an endomorph, I just put on weight looking at food.
So is there any truth to that?
Well, there is some truth to body type, sure.
Yeah.
But the source highlights a study that suggests the belief in your genetics might be just as strong as the genetics themselves.
Wait, what? So it's like a placebo effect?
In a way, yes. There's research showing that if you tell someone they have the genetic marker for high endurance, even if they absolutely don't, they actually perform better on endurance tests. They push harder because they believe they are built for it.
And the flip side?
If you tell them they have bad genes for strength, their physiology essentially downregulates.
No way.
They give up faster, they recruit less muscle mass, they mentally check out because they think the outcome is predetermined.
That is wild. It's a self-fulfilling prophecy.
Precisely. Now, to be clear, the book doesn't say genetics don't matter. They do. They probably determine your absolute ceiling, how far you could possibly go.
If you train like a pro for 20 years.
Right. But for 99% of us, that bad genes excuse is a psychological wall, not a physiological one. Everyone has the biological machinery to adapt and get stronger.
So stop blaming your parents and pick up the weight.
Okay, so another huge barrier is age, and this cuts both ways.
Right. Too young or too old.
You have parents terrified that lifting weights will stunt their child's growth, and then you have older adults thinking, they've missed the window.
Let's tackle the kids first, because that myth about stunting growth is incredibly persistent.
It really is.
And it likely comes from old studies on, malnourished children working in factories in the 1800s, not athletes in a gym.
So it's not the barbell's fault.
Not at all. Austin Current clears this up immediately. With proper supervision, strength training is safe and beneficial, starting around age 11 for girls and 13 for boys.
That's right around puberty. Exactly. It helps with motor control, bone density. It sets up lifelong habits. It's not about having a 12-year-old max out a deadlift.
No.
It's about teaching them how to move their body against resistance.
Okay, and for the older crowd, the "it's too late for me" demographic?
The source is very firm on this. It is never too late. In fact, as you age, resistance training shifts from being exercise to being a medical necessity.
A medical necessity.
It is the single most effective intervention for preserving independence.
We'll get into the specifics of aging later, sarcopenia and all that fun stuff, but I think the takeaway here is that strength training is basically the fountain of youth.
It's the closest thing we have to a magic pill, really.
Now, we have to address the third big myth. This one is usually specific to women, but I hear it constantly.
The fear of getting bulky.
Yes. I have friends who say, I'll do cardio, maybe some light yoga, but I'm not touching the heavy weights because I don't want to look like a bodybuilder.
And this is just a fundamental misunderstanding of endocrinology. To get bulky, that massive, thick muscle look, you generally need two things. A specific style of high-volume training and, crucially,
Testosterone.
a lot of testosterone, which women naturally have much less of.
Right.
Significantly less. Women have higher estrogen levels, and estrogen actually limits that excessive tissue buildup. So biologically, the Hulk outcome is extremely difficult for a woman to achieve naturally.
You'd really have to work at it.
You practically have to treat it like a full-time job.
But the book makes a really nuanced point here that I liked. It says women and men actually experience similar relative gains.
Right. So if a man and a woman both start a program, they might both increase their strength by, say, 20% in a few months.
Okay.
But because the woman's starting baseline for muscle mass is lower and her hormonal profile is different, that 20% increase results in a lean, athletic look, not a bulky one.
So you get the strength without the size that people are afraid of.
Exactly. You
Yeah.
get the capability without the circumference. You become a more efficient machine, not necessarily a larger one.
Okay, we've busted the myths. Mental hurdles are cleared. Now I want to go into the lab. The book has these incredible diagrams that take us from the person standing in the gym all the way down.
To the microscopic level.
It's like the magic school bus for lifting.
It really is. We need to zoom in. If you look at your bicep in the mirror, you see the muscle belly. That's the macro view. But if we were to slice that open...
Please don't try this at home.
No, please don't. But if we did, we'd see bundles called fascicles. Slice those open, you get muscle fibers.
It's like a Russian nesting doll situation.
It is. And inside the fiber, you have myofibrils. And inside those, that's where the magic happens. We get down to the sarcomere.
The sarcomere, it sounds like a sci-fi villain. The sarcomere is attacking.
It's actually your best friend. Think of the sarcomere as the engine room. It's where chemical energy turns into mechanical motion.
Okay.
Inside this tiny unit, you have two main filaments, actin and myosin.
The book uses the rowing analogy here, which I found really helpful because molecular biology can get dry fast.
It's the best way to visualize it. So imagine a rowing shell boat. The myosin filament is the rower. It has these little heads or oars.
Okay.
And the actin filament is the water.
Okay, so how do they move? How does the boat go?
It's called a sliding filament theory. Your brain sends a signal, an electrical impulse, that floods the cell with calcium. This calcium basically unlocks the door, clearing the way for the myosin head to reach out and grab the actin it locks on.
That's the catch in rowing.
Then it performs the power stroke. The head pivots, pulling the actin filament toward the center of the sarcomere. This physically shortens the muscle.
So when I curl a dumbbell, that's just millions of little rowers taking a stroke at the same time.
Exactly. Millions of microscopic power strokes shortening the distance. But here's the part that blows people's minds.
Uh-oh.
To let go, that costs energy.
Wait, letting go costs energy? I thought relaxing was free.
Not at the cellular level. It takes an ATP molecule, pure chemical energy, to bind to that myosin head and force it to detach. It resets the oar so it can grab again.
So if you ran out of energy completely, you wouldn't go limp. You'd lock up.
Exactly. That's what rigor mortis is. When a body dies, it stops producing ATP. The pumps stop working, and the muscles stay permanently contracted because they literally can't afford the energy costs to let go.
That is grim, but it really illustrates the mechanism. Okay, so we have these billions of little rowers inside us, but not all rowers are the same, right? We have different crews.
Right. We classify them as fiber types. You primarily have type 1 and type 2.
Slow twitch and fast twitch.
Exactly. Type 1 fibers are your marathon runners. They are smaller, they have a lot of blood supply, and they are incredibly efficient. They can keep that rowing motion going for hours without getting tired.
But they're not super strong.
No, they don't generate a huge splash.
And type 2.
Those are your power lifters or sprinters. They are larger and can generate a ton of force very quickly, but they're inefficient. They burn through fuel fast and fatigue quickly.
And most of us have a mix.
We do. And interestingly, while training can shift the properties of these fibers slightly, your ratio of type 1 to type 2 is largely determined by genetics.
Ah, so genetics do matter there.
Yes. This is why some people are natural sprinters and others are natural distance runners.
Okay, so we know how the machine moves, but the holy grail of this book and of anyone going to the gym is understanding how to make the machine bigger and stronger. We want hypertrophy.
Hypertrophy, the biological term for growth.
Yeah.
But the central question is, what actually tells the body to grow? Because the body doesn't want to add muscle.
It's expensive.
It's very expensive tissue. It takes a lot of calories to keep it alive. So we have to force it. We have to give it a reason to justify the expense.
So what are the signals?
The source identifies 3 specific mechanisms, 3 alarm bells, that signal the body, hey, we need more muscle to survive this environment.
And the first one is the big boss, right?
Yes. Mechanical tension is the primary driver. It's simply the force you apply across the muscle fibers. When you lift something heavy, mechanoreceptors on the cells physically sense the stretch and the load.
Is that why simply lifting a soup can 500 times doesn't build big muscles?
Exactly. You aren't creating enough tension to threaten the structural integrity of the cell. The body says, I can handle this soup can with what I have. No need to upgrade.
But if you lift something near your limit,
Then the body says, whoa, we are near the breaking point here. We need to reinforce.
so tension is king. If you aren't struggling a little, you aren't signaling. But then we have number 2, which feels very different. Metabolic stress. This is the pump.
Right. You know that burning sensation when you're doing high reps? Maybe the end of a long set of lunges?
Oh yeah, the burn, the muscle feels tight and swollen.
That's metabolic stress.
Yeah.
You're working the muscle so constantly that blood can't get in or out fast enough. You create a hypoxic environment, low oxygen, and metabolites like lactate, inorganic phosphate, hydrogen ions start to accumulate.
The acid, that's the burn.
Yes. And surprisingly, that swelling feeling helps growth. The cell fills with fluid pressing against the cell wall. The cell perceives this pressure as a threat to its integrity, and again, signals for reinforcement. This is why bodybuilders often do higher reps with short rest periods. They're chasing that metabolic stress.
Okay, so we have tension from heavy weight and stress from the pump. Then we have the third one. And this is the most controversial one, right? Muscle damage.
Yeah, we used to think damage was the main goal, the old no pain, no gain mentality.
If you weren't crippled the next day, you didn't work hard enough. I still struggle with that. If I'm not sore, I feel like I wasted my time.
The book really corrects that mindset.
Right.
Muscle damage and microtears in the tissue is a stimulus, yes, but it's a double-edged sword. So the source uses a great analogy, the popped sarcomere. Imagine a bendy straw, you know, the corrugated part.
Sure.
If you pull it too hard, those folds pop open and lose their ability to snap back. That happens to your sarcomeres during heavy eccentric lifting. The lowering phase, they physically pop. The structure is disrupted.
That sounds bad.
Well, it triggers inflammation and repair, which can lead to growth. But here's the catch. If you do too much damage, your body spends all its resources just getting you back to baseline. You aren't building a higher skyscraper, you're just repairing the broken windows on the first floor.
That's a great way to put it. So we want to stimulate, not annihilate.
Ideally, you want high tension with moderate stress and minimal damage. That seems to be the sweet spot for consistent growth without burnout.
This leads us perfectly into the how of lifting. Because if damage happens mostly during the lowering part, we need to understand the different ways a muscle moves.
Concentric, eccentric, and isometric.
Right. And most people only focus on the concentric. That's the lifting part. The muscle shortens. You curl the weight up. You stand up from the squat.
But the eccentric is the way down, the lengthening. And this is crucial because you are actually stronger eccentrically.
Wait, really? How?
You can lower significantly more weight than you can lift. Think about it. You might struggle to bench press 200 pounds up, but you could probably control 220 pounds on the way down slowly.
That's true. I never thought about it like that.
That eccentric phase creates the most mechanical tension and the most damage. So if you just drop the weight, if you let gravity do the work, you are skipping half the workout.
You're missing the most potent signal for growth.
Exactly.
Huge takeaway. Control the negative, and then isometric is just holding still.
Holding a plank or pausing the weight mid-rep. Tension without movement. It's useful for stability, but usually not the main driver for mass compared to a full range of motion.
Speaking of mass, the book makes a distinction that I had never heard before. It turns out there are 2 different ways a muscle can get bigger.
Right, not all big is created equal.
This explains the difference between a bodybuilder and a powerlifter.
It does. We have myofibrillar hypertrophy and sarcoplasmic hypertrophy.
Okay, let's break those down. Myofibrillar sounds like The fibers themselves?
It's the contractile proteins. You're literally adding more actin and myosin filaments. You are building a denser engine with more pistons.
Which makes the muscle stronger.
Significantly stronger. This usually comes from heavy weights, low reps, high mechanical tension.
And sarcoplasmic.
Sarcoplasm is the fluid inside the muscle cell. It holds glycogen, which is stored carbs, and other energy substrates. Sarcoplasmic hypertrophy is when you increase the volume of that fluid.
So the muscle looks puffy or full.
Exactly. But it isn't necessarily much stronger.
So that's why you see these massive bodybuilders who look like they could lift a truck, but then a smaller powerlifter might outlift them.
Precisely. The bodybuilder has optimized for fluid volume and metabolic storage sarcoplasmic growth. The powerlifter has optimized for fiber density myofibrillar growth. Both are adaptations, just to different stimuli.
Okay, so we've gone to the gym, we've created tension, we've controlled the eccentric, maybe we got a bit of a pump. Now we go home. This is where the repair crew comes in. And the book introduces the coolest named cells in the human body, satellite cells.
They are the unsung heroes. Satellite cells are muscle stem cells. They sit dormant on the outside of the muscle fiber, just waiting for a distress signal.
They're like sleeper agents, so when we lift, we ring the alarm.
Right. The muscle says, help, we have damage, we have tension. The satellite cells wake up, they multiply, and then, this is the sci-fi part, they fuse into the muscle fiber and donate their nuclei.
They donate their nuclei. Why does a muscle need more nuclei?
Because a muscle fiber is a massive cell. It's huge compared to a skin cell.
Yeah.
One nucleus, the command center, can't manage the whole thing.
It's like trying to run a massive factory with just one foreman.
Perfect analogy. As the factory gets bigger, you need more foremen to manage protein synthesis. Satellite cells provide those extra managers.
And this connects to muscle memory, doesn't it?
It does, and this is so encouraging. Once you acquire those nuclei, they tend to stay there, even if you stop training for a while.
Oh, wow.
The muscle might shrink because the fluid and proteins decrease, but the managers are still in the building. That's why it's easier to get back in shape than it was to get in shape the first time.
That is incredibly cool. But there is a flip side to this. If we don't use these systems,
They degrade.
sarcopenia.
The age-related loss of muscle mass. After age 30 or 40, if you were sedentary, you naturally lose a small percentage of muscle every year.
And dynapenia.
That's the loss of strength. And strength actually declines faster than mass. It's a neurological use it or lose it.
But the book emphasizes that this isn't just about looking good or being able to open a jar of pickles. It's about your bones.
This was a major highlight for me. We think of bones as dead scaffolding, like dry sticks inside our body.
Yeah, that's what I always pictured.
But bones are living, dynamic tissue. They are constantly remodeling. There's a constant battle between osteoclasts, which break down bone,
The demolition crew.
and osteoblasts, which build bone. The construction crew.
Okay.
Now, the construction crew, the osteoblasts, they're lazy. They only work when they sense pressure. They need mechanical loading.
So they need to be told to work.
Yes. When you lift weights, the tendon pulls on the bone. That tension sends a signal. The structure is under stress. Thicken the walls.
So if you just sit on the couch.
The demolition crew keeps working, but the construction crew takes a permanent coffee break.
Yeah.
Your bones get porous and brittle. That is osteoporosis.
So lifting weights is literally telling your skeleton, do not dissolve.
It is the only way to send that signal effectively.
Yeah.
Walking isn't enough tension. You need load.
That reframes everything. It's not about vanity, it's about structural integrity.
It connects the whole system. The nervous system fires the signal, the muscles create the tension, the chemical energy cycles through the sarcomeres, and the bones reinforce themselves to handle the load. It's a complete biological symphony.
So bringing this all back to the listener who might be standing in the gym right now looking at the dumbbell rack, how does this change their workout today?
I think it changes the intent. You stop just going through the motions.
No more mindless reps while looking at your phone?
Right. When you understand that mechanical tension is the driver, you start swinging the weights. You focus on making that tension consistent. When you understand the eccentric phase causes the adaptation.
You control it down.
You stop dropping the bar on your chest, you control it down.
Yeah.
You start respecting the biology.
And you stop chasing soreness.
You chase progression. Are you stronger than last week? Are you creating more tension? That's the metric.
And most importantly, you stop worrying about the things you can't control. The bad genes.
That's the big distraction.
I want to leave everyone with a thought based on that section of the book. It mentions that accurate genetic testing is basically out of reach for most of us, and honestly, it's mostly irrelevant.
Unless you are trying to win gold at the Olympics, your genes aren't your limiting factor.
Right. So consider this. We spend so much mental energy worrying about our ceiling. Am I an ectomorph? Is my metabolism too slow? But if you simply focus on the biological certainty we just discussed, that tension creates growth and load creates density, how much potential are you leaving on the table right now by worrying instead of lifting?
Biology works. It's a machine. You just have to operate it.
So go apply some tension. Thanks for listening to the deep dive.
See you next time.